Hi students, so in this video I'm going to show you how to solve a problem involving simply supported beams. Basically you got a beam here which is supported at two places, and because of the support you'll have two reaction forces, that is AV and BV. Now what you need to do for this problem is calculate the support reaction AV and BV, that is these two forces here. You got to find the magnitude of them. So how do you go about solving a problem like this? So first of all, we have to make sure that all of our forces are known. So you got a force here 12 kilonewton and another force here universally. Now this is a universally distributed load of 62 kilonewton. That means you got 62 kilonewton acting on this entire plane here. So what you need to do is basically you need to find, as a result of this 62 kilonewton acting on this whole plane, you need to find the net resultant, that is the force acting on one point because of this universally distributed load. How do you go about doing that, and where exactly will that force lie? So now we know, looking at the diagram, it is a distance of 2 meters. So whenever you have a universally distributed load, you always consider that that load acts at the midpoint of the distributed load. So because this is 2 meters, my net resultant because of the UDL will be somewhere over here, that is 1 meter from here, 1 meter from here, 62 kilonewton, and I'm going to mark the position here. That's 1 meters, and that's 1 plus this one, so 2 meters, 1 meter, because that's the this is the midpoint of this line here. Now in order to find the reaction force AV, we take the moment across BV, and in order to find the reaction force BV, we take moment across AV. So let us start with finding BV first. So what we do is we take moment across AV. So moment, summation of all moment across A will be equal to the force times the magnitude of the force times the perpendicular distance of the action of the force from the point in consideration. So over here it is our point AV here. So the first force will be AV times the perpendicular distance, which is 0 because force AV acts on that point. So that's going to be AV times 0. Then second force is 12 kilonewton. That's going to be 12 times distance is 1. Third force is our universally distributed load, which we are considering is acting at one point over here, that is 62. Now just make a note over here, I have left spaces when I'm writing my numbers down. That is for a reason, because I'm going to enter my sign convention later. That's 62 times perpendicular distance, so that's 1 meter, and that's the second meter, or 2 meters in total. And the last force is my BV, and the distance is 1 plus 2, that's 3 meters. BV times 3. Now we take a look at the sign convention. So what I'm going to do is any force going downwards will be positive, and hence upwards will be negative. So anything going downwards, AV is going upwards, so that's going to be negative. 12 is going downwards, so it is going to be positive. 62, it is going downwards, so it is going to be positive. And BV is going upwards, so that's going to be negative. So this is my equation for the movement of all forces across point A. Now, because this is a simply supported beam and the net resultant of all this system is 0, that is, you got these forces over here, they will stay as they are and your system will not move. Hence, I can say that my movement across A is 0. So I'm going to say, because the system is stationary, summation of movement of all forces across A will be 0, and therefore I substitute that in my equation. 0 will be equal to, that is going to be 0 plus 12 plus 62 times 2 is 124 minus 3 BV. Hence, getting all my numbers on one side and keeping the unknowns on the other, minus 12 minus 124 will be equals to minus 3 BV. Hence, 124 plus 12 is 136 with a minus sign. Will be equal to minus 3 BV. Hence, BV will be 136 divided by 3, that's minus and minus, which gets cancelled out. So 136 divided by 3 will be 45.3. And now, once we have the value of BV, we can now find the force AV. So what we now do is we take moments across BV. So again, summation of all movements across B will be, that's the force there now, BV times 0 plus second force is 62 times, and that's at a distance, so that's 2, so that is going to be 1, and any force going downwards is positive, so that's why 62 is positive BV. Second force is third force is 12 kilonewton going downwards, that's going to be plus 12 times 2, and the last force is AV, it's going in the upward, so that's going to be minus AV times 3, and hence again, because the system is stationary, movement of all forces across B will be 0, and hence 0 will be equal to 62 plus 24 minus 3 AV, and hence minus 3 AV. Taking both these numbers on the other side, 62 plus 24 is 86 62, 72, 82, plus 4, 86, with a minus sign. Hence, AV will be 86 over 3 minus and minus become a plus, and hence AV will be equal to 86 divided by 3, 28.6. Hence we got our two forces. AV will be equals to 28.6. BV will be equal to 45.3. And always remember the units: kilonewton, kilonewton. This is how you solve a problem on simply supported beams.